In this video, we're going to talk about the cosine rule first. So the cosine rule is normally proven using two forms of triangles, the acute triangle and the obtuse triangle. So in case of if you're not sure, an acute triangle is a triangle that all its angles are less than 90 degrees, while an obtuse triangle is a triangle that one of its angle is greater than 90 degrees. So the rest are often less than 90 degrees. We are going to first start with proving the cosine rule using the acute angle way. This angle of A has an opposing side of A. This angle of C has an opposing side of C. This angle of B has an opposing side of B. So if we decide to split our triangle into two, we'll have two right angle triangles. So this is a right angle triangle, this is a right angle triangle. Let's say this is split into X. That means here will be A minus X, because everything from here to here is A. So from here to here is X, here to here is A minus X. So we are going to deal with these two triangles differently. So starting with this triangle here, I'll be using the Pythagoras theorem to find the value of C. C square is equal to A minus BX and then square. This, let's say the triangle has a height of H, so this is plus H square. So from here we can see C square is equal to minus X, open bracket A minus X plus H square. So we have C square is equal to A times A is A square. A times minus X is minus AX. Minus X times A is minus AX. Minus X times X is plus X square plus H square. So this is equal to A square plus X square plus H square minus 2AX. So we've dealt with the first triangle. Now in the second triangle, if we use Pythagoras theorem, we'll have B square is equal to H square plus X square. Now if you notice, this term here appears here. So we can replace this with B square, right? So that C square is equal to A square plus B square minus 2AX. To get the value of X, because we're working with a right angle triangle in this case, you can use SOHCAHTOA. So to get the value of X, we'll say cos C is equal to the adjacent over the hypotenuse. So this is equal to, the adjacent is, if this is the angle, the adjacent is X here and the hypotenuse is B. So this is X over B. So that X becomes equal to B cos C. So we can now plug the value of X back into this equation. So it becomes C square is equal to A square plus B square minus 2AB cos C. So if we write this here, we have C square is equal to A square plus B square minus 2AB cos C. Depending on where we cut this triangle from and make it two right angle triangles, it can change. This value can change. So it can be A square is equal to B square plus C square minus 2BC cos A. And then it can be B square is equal to A square plus C square minus 2AC cos B. So let's prove the cosine rule for an obtuse triangle. So for an obtuse triangle, the first thing we do is we draw another imaginary line here to make it look like a right angle triangle. So this is H, we call this H. Note that this is angle C. This is angle C. This is 180 minus angle C. Let's call this angle theta though. So if this is angle theta, this is angle C. So that means C plus theta is equal to 180 degrees. Now we're going to be dealing with two right angle triangles. So this is the first right angle triangle here. And then general as a whole is the second right angle triangle. So note that before, this is the angle C. So this is side C. This is the angle B. This is side B. This is the angle A. This is side A. If this is side A, this is side X. So the whole of here to here is simply A plus X. Simply A plus X. So dealing with a smaller triangle inside here, we are going to be using Pythagoras theorem as we did before. We have b squared is equal to x squared plus h squared. So we are done for that one. Now dealing with the bigger triangle, we have c squared is equal to x plus a plus x squared plus, and then the height is h squared. So this is c squared is equal to, expand this bracket, you have a squared plus x squared plus 2ax plus h squared. So bringing this over to here, we have c squared is equal to a squared plus 2ax plus x squared plus h squared. Now remember, x squared plus h squared is b squared. So you can pull it inside here and say c squared is equal to a squared plus 2ax plus b squared. So that it looks like a squared plus b squared plus 2ax. Now I want to get the value of x. So how do we get the value of x? So this angle here is angle theta. Now we know that c plus theta is 180. So that theta is equal to 180 minus c. So you can use to relate the hypotenuse to the x value that we assumed. From there we can say, so we know we have say cos theta is equal to adjacent, which is x over b. So x over b. Cross multiplying, this implies that x is equal to b cos theta. But we don't actually know cos theta from the equation. This is just an assumed angle. So we replace it with what we know, 180 minus c. So x is equal to b cos 180 minus c. So this is equal to cos 180 minus c can also be said to be equal to, cos 180 minus c is also equal to minus cos c. So replace cos 180 minus c with something more direct as minus cos c. So this is equal to b times minus cos c. So we have x is equal to minus b cos c. So we can put x back into this equation. So we have c squared is equal to a squared plus b squared minus 2ab cos c. So that's basically the same thing as we did before. Depending on which side we're looking at, this equation could be b squared is equal to a squared plus c squared minus 2ac cos b. A squared is equal to b squared plus c squared minus 2bc cos a. So that's how to prove the cosine using an obtuse triangle. So thanks for watching the video. If you liked it, share with your friends, leave a like button, subscribe to the channel. Thanks for watching again.